Good afternoon, students.
Good afternoon, ma'am.
Okay, shall we start with the class?
Yes, ma'am.
So today we are discussing moving charges and magnetism. This is the fourth topic according to your NCERT textbook. But till now, whatever topics we have completed, six topics totally we have completed. So I'll just remind you people, that is first one, electric field and charge we have completed. Then electric potential. Then after that, current electricity. Then fourth topic, electromagnetic induction we have completed. Alternative current we have completed. So this will be the sixth topic, that is magnetism and matter, sorry, moving charges and matter. Then next, magnetism and matter also we will complete. So electromagnetic waves, hardly one question, it may come, may not come. Okay, so for that reason we will complete these two topics today itself if possible. Then next class we can go to the part 2. So part 2 physics textbook, whatever it is there, that we will start. Okay, so let us see the first question here. From moving charges and magnetism and matter, little theory based questions are more here. Okay, so let us start the class. See here, the first question is, when iron fillings are sprinkled around the current carrying wire. So understand the question first because it is a theory based question. So what they are saying, when iron fillings, so you have the iron fillings which is sprinkled around the current carrying wire. So you have a current carrying wire around this, that is iron fillings are sprinkled here. Okay, so what happens? They arrange themselves in concentric circles with the wire as the center. They reveals the pattern of magnetism around the wire. The field lines are more concentrated near the center. All of this. Yes. So when the iron fillings are sprinkled around the current carrying wire, which one will be the truth statement? Option. That is, all the statements are true here. That is, they arrange themselves in the concentric circles. That is also true. So whatever the concentric circles pattern you are able to see around the wire, Elaine ಹೇಳ್ತಾ ಇದ್ದಾರೆ, that is here whatever the wire you are placing, a current carrying wire, when iron fillings are there around this, so this will align in the form of the concentric circles. Okay, so to understand, take it in the vertical line. So this will align in this pattern. Okay, so that is nothing but the concentric circles it will form. So second one, what they are saying, they reveal the pattern of the magnetism around the wire. Yes. So what this circle it is telling you, that is the magnetism around the wire. Third statement, what it is, the field lines are more concentrated near the center. So here near the center, the magnetic field lines are more concentrated. As you go away, the strength will decrease. The strength will decrease. Therefore, all the statements are true. Okay, so moving towards the next question. The laws obeyed by electricity and magnetism were uniformed and formulated by. Means here what they want to say. So in the first three topics, you studied about the electricity. In this chapter, you will study about the magnetism. So who unified this? Unified in the sense, who combined, that is presence of electricity gives magnetism. Presence of magnetic field indicates there is a presence of the electricity. ಅಂದ್ರೆ ಎರಡನ್ನು ಯಾರು ಕಂಬೈನ್ ಮಾಡಿ ಲಾ ಹೇಳಿದ್ರು, that is J.C. Bose, James Maxwell, Marconi, Hans Christian Ørsted.
Option D.
Yes. So that is option B, unification of the law of electricity and magnetism was formulated by Maxwell. So experiment ತೋರಿಸಿದ್ದು Ørsted. Experiment was given by Ørsted, but law was given by, that is the Maxwell, in the year of 1964. Next question. When a magnetic compass needle is carried near to a straight wire carrying current, then, so understand the question, when a magnetic compass needle is carried near a straight current carrying wire. So here you have the current carrying wire. So for this current carrying wire, what you are going to do, you are going to get the compass needle. So hope so you know what you mean by the compass needles. So compass needles in the sense which will show, that is the poles, that is the north and the south pole. So this compass needle, when you take it near, so you are taking it near to the current carrying wire. So two statements they have given. The straight wire cause a noticeable deflection in the compass needle. So first statement ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, the needle will show the deflection. Second statement is the alignment of the needle is tangential to an imaginary circle with straight wire as its center and has a plane perpendicular to the wire. Means here whatever the wire is there, it will produce the magnetism. So here what they are saying, here the magnetism will be there. When you get this compass needle, this deflection, deflection will be tangential to your this magnetic field lines. Okay, so this is first statement is right. Options ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, first statement is right, second statement is right, both the statements are right, neither one nor two is right.
Both the
Both
options
are true. Option C, that is both the statements are true here. Okay, so here you can see that is, and these are the result of the experiment done by the Christian Oersted. So Oersted in experiment ಹೇಳ್ತಾರೆ, that is clear statement is given here. So here the next question. Which one of the following is not correct about Lorentz force? So Lorentz force, as you know that Lorentz force is the law which gives the relation between the magnetism and the current. So magnetism ಮತ್ತೆ current ಅನ್ನ combine ಮಾಡಿ Lorentz law ಹೇಳುತ್ತೆ. So here see, in presence of the electric field and magnetic field, the force on a moving electric charge is given by. So here the force is given by, the expression is written F is equal to QE plus V cross B. So bracket ಅಲ್ಲಿ R ಅನ್ನೋದು vector indicate ಮಾಡ್ತಾ ಇದೆ. Next option B, the force due to magnetic field on a negative charge is opposite to that on the positive charge. So here the force due to the magnetic field is opposite to that of the positive charge. Option C ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, the force due to magnetic field becomes zero if velocity and magnetic field are parallel or anti-parallel. Option D, for a static charge, the magnetic force is maximum. Not correct, okay? Not correct, which is not right. So first statement, it is right because it is nothing but the expression for the Lorentz force. So idu sariyagide, this is true. What about B, C, D, which is wrong among B, C, D?
option B, ma'am.
Option B, let's see. Option D is 0. That is for a static charge, the magnetic force is maximum. For static charge, the magnetic force is maximum. So here you can see, for a static charge means, so when you say that the static charge, which means that the velocity becomes 0. For the static charge means the charge is at rest. Okay, statics ಅಂತಂದ್ರೇನು rest ಅಂತ ಆಗುತ್ತೆ. So when the charge is at rest, obviously the velocity becomes 0. So when the velocity becomes, the magnetic force is given by QVB. So when the velocity is 0, the force becomes 0. The magnetic force becomes 0. But option D ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, the magnetic force is maximum when the static charge is there. So actually, when the static charge is there, the magnetic force will be 0. So that is not true. Remaining all are the true statements. Next question. In an inertial frame of reference, the magnetic force on a moving charged particle is F. Its value in another inertial frame of reference will be. So here we have inertial frame and the non-inertial frame. Hope so you remember in the first year we studied this. So we have two types of frames of reference, that is inertial frame of reference, and the second one is non-inertial frame of reference. So inertial frame of reference means where Newton's laws are valid. So you know that is Newton's law. 3 laws are there. So first law, that is for unless and until the force acts on a body, the body will not change. The second law, that is F is equal to ma. The third law, for every action there is equal and opposite reaction. So these are the Newton's law. So yav frame of reference ಅಲ್ಲಿ Newton's law is valid ಆಗತ್ತೆ, those are called as the inertial frame of reference. Means we are in the inertial frame of reference because the Newton's laws are valid. So non-inertial frame of reference means what? Where the Newton's laws are not valid. Okay, for example, in the space. So in the space, the Newton's laws, we cannot say the Newton's laws are verified there. So that is non-inertial frame. Inertial frame where the laws are verified. Okay, so Elaine ಹೇಳ್ತಾ ಇದ್ದಾರೆ, in an inertial frame of reference, the magnetic force on a moving charged particle is F. So moving charge of particle ಮೇಲೆ F ಇದೆ. Its value in another inertial frame of reference. So one inertial frame of reference ಅಲ್ಲಿ the magnetic force is given by F. What about in the another inertial frame? What happens to the magnetic force? It remains the same. Option B, change due to the in the amount of the charge, change due to the change in velocity of the charged particle, changed due to the change in the field direction. So whether it will remain change or it will remain same or it will change due to three factors. ಒಂದು ಡೈರೆಕ್ಷನ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಒಂದು ವೆಲಾಸಿಟಿ ಬಗ್ಗೆ, ಒಂದು ಚಾರ್ಜ್ ಬಗ್ಗೆ. ಸೊ ಇದು ಚೇಂಜ್ ಆದ್ರೆ ವೆದರ್ ಇಟ್ ವಿಲ್ ಚೇಂಜ್ ಆರ್ ಇಟ್ ವಿಲ್ ರಿಮೇನ್ ಸೇಮ್. So here option C, that is it is changes due to the velocity of the charged particle is changing, because what happens here, velocity depends on the acceleration. So in the frame, inertial frame of references, if you have different inertial frame of reference, the acceleration due to gravity will be different. So yaವಾಗ acceleration due to gravity different ಆಗತ್ತೆ, velocity will be changing. So velocity will be changing, therefore what happens, the magnetic force also changes, because they have given that F is equal to QVB sin theta. So actually, see, which shows magnetic field is velocity dependent, due to which it differs from one inertial frame to another inertial frame. Actually, it depends on charge also. See, change due to the change in the amount of the charge, because here what happens, it is depending on charge also. So it may change due to charge also. So in general, what you can say, frame of reference change adre magnetic force value change agatte. Okay, moving towards the next question. This one you can answer. See, which is the expression for the magnetic force? See, magnetic force on a current carrying conductor of length L in an external field B, it is given by. So which is the expression?
Option C.
Yes, option C is the right answer. That is IBL or BIL, however you want, you can remember. So here in this chapter, there are 2 points. The force due to the charge is given by QVB. The force due to the conductor, ಇಲ್ಲಿ conductor ಅಂತ ಹೇಳಿದ್ದಾರೆ. So due to the conductor, it is given by ILB or BIL. Okay. So due to charge ಅಂದಾಗ Q term ಬರಬೇಕು, due to conductor ಅಂದಾಗ length term ಬರಬೇಕಲ್ಲಿ. So like that you can remember for your reference. Yes, so calculation part. See, a straight wire having mass of 1.2 kg and length of 1 meter carries a current of 5 ampere. If the wire is suspended in mid-air by a uniform horizontal magnetic field, then the magnitude of the field is. So here mass is given as 1.2 kg, length is given as 1 meter, current is given as 5 ampere. It is suspended in the mid-air by a uniform horizontal magnetic field. So what is the value of the magnetic field? Current, length, mass is given. Yes. So it is suspended. Here what you need to understand, what they are saying, it is suspended in the mid-air. So when it is suspended in the mid-air, itara suspension iddaga, always this type of question, what you need to do, you need to balance two types of forces. So one will be the downward force, that is the weight, that is mg. One will be the upward force. So here the force, two forces yavadanta andre, one is the magnetic force. So conductor anta helidare. So when it is specified as conductor, the magnetic force is given by ILB. ಈ ಫೋರ್ಸ್ ಎದಕ್ಕೆ ಇಕ್ವೇಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ ನೀವು? ದಟ್ ಇಸ್ ಫಾರ್ ದ weight, because weight is nothing but the force itself, right? So ಯಾಕೆ equate ಮಾಡ್ತಾ ಇದ್ದೀವಿ? Because here the wire we are suspending. So ಯಾವಾಗ ಮಿಡ್ ಏರ್ ಅಥವಾ ಮಿಡ್ ಅಲ್ಲಿ ಸಸ್ಪೆಂಡ್ ಆಗಿರುತ್ತೆ, that time, so one will be the downward force, one will be the upward force. So maximum this type of question you need to take the equation, two equations you need to equate. So here you need to calculate the value of the magnetic field, which is given by mg upon I into B. You can see the calculation, students. If any doubt is there, you can ask. Otherwise, you can copy down. So mass is 1.2 kg. Acceleration due to gravity 10 anta tagoli. Current is 5 ampere. Then magnet length is 1 meter. Sorry, this is L. I into L. You can substitute all the values. 1.2 into 10 upon I value is 5 into 1. So simple calculation, answer is 2.4 Tesla. So in CET or any competitive exam, for calculation purpose, you can take acceleration due to gravity value as 10. Okay. So moving towards the next question. See, a circular loop of radius R carrying a current I is placed in a uniform magnetic field B perpendicular to the loop. The force on the loop is, so what happens to the force on the loop? What they are saying here, see, that is you have a circular loop and whose radius is R, which is carrying a current of I, and it is placed in the magnetic field of B, but it is perpendicular to the loop. It is perpendicular to the loop. Magnetic field and this whatever the circular loop is there and the magnetic field are perpendicular to each other. So what happens to the force they are asking? You need to calculate the value of the force. Yes. See, as you know that it is a wire. So wire means here what happens, that is IBL sine theta. They are saying it is perpendicular. So therefore the answer will be what? 0. So when perpendicular parallel anta heltare, that time little you need to think. Okay, so if you think the expression, you will understand. Right? So 0 will be the answer.
Ma'am, if it is parallel, then what's the answer?
If it is parallel, then you need to calculate that one. Then here, whatever the expression they have given, actually none of them are correct here. So for the circular loop, that concept actually it is deleted. If you remember, that is, which is that here one expression is there for the circular loop. At the end, I'll tell you about this one. Actually, this part is deleted, but here as they're specifying it as perpendicular, you take it as 0. Otherwise, the magnetic field expression is given. I'll tell you the formula at the end. So in that you can substitute and calculate that one. See the next question. A 2.5 meter long straight wire having mass of 500 gram is suspended in mid-air by a uniform horizontal magnetic field B. If a current of 4 ampere is passing through the wire, then the magnitude of the field is. You can calculate this. So it is again a wire suspended in the mid-air. You can try this one. Is the answer is option A. That is mg is equal to IBL sine theta.
Yes, ma'am. Yes, ma'am.
Okay. So the next question. See the next question. A current of 10 ampere is flowing in a wire of length 1.5 meter and a force of 15 Newton acts on it when it is placed in a uniform magnetic field of 2 Tesla. The angle between the magnetic field and the direction of the current is. So you have a current of 10 ampere which is flowing in the wire of length 1.5 meter. So you have a wire. So this wire is having current of 10 ampere and its length is 1.5 meter and the force acting is 50 Newton. What they are saying, when it is placed in a uniform magnetic field. So the magnetic field value is given as 2 Tesla. Here, what is the value of the magnetic field and the direction of the current? Means theta value you need to calculate. So what you will do, that is F is equal to, again it is a conductor, IBL sine theta. So you can calculate the value of just theta. Remaining all values are there. Force is there, length is there. All values are given. Yes, theta is equal to how much you are getting?
Getting 30.
Yes. So here sine theta is equal to, it is 1 by 2. Therefore, theta will be, it is 30 degree. Theta will be 30 degree. So moving towards the next question. Again, it is a numerical question. A horizontal component of Earth's magnetic field at a certain place is 3 into 10 raised to minus 5 Tesla. So here the magnetic field value is given. This is having a direction from the geometric south to north. The force per unit length on a very long straight conductor carrying steady current of 1.2 ampere in east to west direction is. Here you need to calculate the force per unit length. Okay, two parallel wires are there. Yes. So here that is, they are asking you to calculate force per unit length. You have the expression F is equal to IBL sine theta. So therefore, force per unit length means what? Force upon length is equal to, it becomes IB sine theta. You have the value of the current, which is 1.2. The magnetic field value is given as 3 into 10 raised to minus 5 into sine 90 is, it is 1. So therefore, here if you simplify it, it will be 3.6 into 10 to the power of minus 5 Newton per meter. Simple. Is completed?
Yes, ma'am.
Okay, the next question. See, the magnetic force per unit length on a wire carrying current of 10 ampere and making an angle of 45 degree with the direction of the uniform magnetic field of 0.20 Tesla is. So again, same question. Same question in the sense, same way you have to solve. Force per unit length you need to calculate. Current is given, angle is given, magnetic field is also given. Check.
Option B, ma'am.
Yes, option B is the right answer. So F by L is equal to 10 into 0.2 into 1 upon root 2 because sine 45 is 1 upon root 2. Therefore, it becomes 2 by root 2. Moving towards the next question. A circular coil of 220 turns and 10 centimeter radius is placed in a uniform magnetic field of 0.10 Tesla, normal to the plane of the coil. If the current in the coil is 5 ampere and the cross-sectional area is 10 raised to minus 5 meters square, and the coil is made up of copper wire having free electron density, that is 10 raised to 29 per meter cube, then the average force on each electron in the coil due to the magnetic field is. So here force you need to calculate. Number of turns, capital N value is given. Radius is given. Magnetic field. Then area, current, yeah, small n value. These all values are given. You just note down the values first. Capital N, radius, magnetic field, current, area, and the value of small n is 10 raised to 29. Okay, so here they are asking you to calculate the force on each, that is each electron. Here we know that is the relation between the current and the drift velocity from the current electricity chapter. That is I is equal to NEA VD. Here, if I calculate E into VD, okay, so E into VD will be what? It is I divided by N into A. E is charge of the electron. VD is the drift velocity. So those values, that is drift velocity values are not there, but I value, A value, N value, everything is given in the question. Here, what we are going to do, this equation, whatever this equation is there, that is I divided by N into A, which is equal to E into VD. For this equation, we are multiplying B on both the side. B is what? It is the magnetic field. Okay, so B is the magnetic field. If I multiply here, again, if I cancel, the same equation I'll get, right? So therefore, I'm multiplying B on both the side. So why we are multiplying this one on the both the side? Because here, whatever expression you are seeing here, that is EVD into B, this one. This is nothing but the force on the charge. I'll tell you how it is. The force, the magnetic force due to the charge is given by, due to charge andre electron irbodu, proton irbodu, anything. Okay, so due to the charge is given by QVB. Okay, so QVB, Q means what? In the question it is specified it as electron. Therefore, charge, I'll replace it by charge of the electron. Here velocity, I'll take it as drift velocity. Why? Because when it is moving in the electric magnetic field, the electron will get drifted. Okay, so drifted andre adenagutte due to the magnetic field electrons accelerate agta hogutte. So therefore the drift velocity we can consider, and this magnetic field write it as it is. So therefore this is nothing but your magnetic force expression. So they are asking you to calculate the force itself. Therefore this is force, and force ನೀವು ಎದ್ರಲ್ಲಿ ಬರ್ಕೊಂಡ್ರಿ current into magnetic field upon that is electron density into the area. So these all values are given. So this is how we have modified the formula, because our kottiro data prakara it is not possible to calculate the force, right? So if you calculate qvb, here the value of velocity is not given, right? And magnetic field is there, but velocity find out madlikke possible illa. We can try the other method, but lengthy agutte. The shortcut method is what? We can connect the formula, that is current is equal to NEAVD. This expression what we are doing, EVD we are keeping on one side, I divided by N into A. Now on both the side, if I multiply the magnetic field, next this entire term is nothing but what? The magnetic force F. So now we have the magnetic force in terms of IB upon NA. So I value kottidare, B value, N value, A value. All the values are there. Just substitute and calculate the magnetic force. Yes, understood student? Solution?
Yes, ma'am.
Okay, so velocity we can find out and we can do, but that will be the 2 steps, but this is a 1-step solution. See, so copy down this one.
Ma'am, I have to.
Okay, the next question. Which one of the following is correct statement about the magnetic force? Magnetic force always obeys the Newton's third law. It do not obey the Newton's third law. For very high current, magnetic force obeys Newton's third law. Inside low magnetic field, magnetic forces obeys Newton's third law.
Option B, ma'am.
Option B, do not obey. Yes. Magnetic forces transmit with finite speed, that is C. Andre Newton's third law will valid agala. Why? Because magnetic force will little change due to the that is the speed. Okay, there is nothing but velocity. Next, a charged particle is moving on circular path with velocity v in a uniform magnetic field B. If the velocity of the charged particle is doubled, then the strength of the magnetic field is halved. What happens to the radius? So previous question I told you about the circular wire, circular path. Regarding that only this question is there. One experiment. Okay, cyclotron. Yes, cyclotron is deleted. See, other the previous concepts alli now actually then study ಮಾಡ್ತೀವಿ. You can see here how you can relate this. See here, that is the force due to the charge. Here the force due to the charge is given by what? That is due to the charge, it is QVB. Okay. So when you have the circular path, the force is given by, we know that it is the centripetal force mv square by r. So we can equate these two equations, that is QVB is equal to mv square by r. So here what happens? V will get cancelled. So namge radius is equal to bekagide. Therefore radius is equal to, it will become mass into velocity, because only one velocity cancelled V, and divided by it is Q into B, right? So according to the question, what they are saying, the velocity is becoming twice. The velocity is becoming twice and the magnetic field is becoming half of the initial value. Means new magnetic field is half of the initial value. New velocity is twice of the initial value. Okay, so according to this, radius find out madidre, new radius will be r dash anta tagolta idivi. So new radius will be, it is m v dash upon q b dash, which is equal to m into v dash is what? 2 into v upon q into b dash will be b by 2, or it is 2 divided by b. So which means that it is 4 times. So 4 times of the original radius. So according to the question, see radius enagatte andre it becomes 8 times, 4 times, 2 times, 16 times, that is 4 times. The radius becomes 4 times of the initial value. Understood?
Yes, ma'am.
Okay, so the next question. See, an electron of energy 1800 electron volt describes a circular path in magnetic field of flux density 0.4 Tesla. The radius is given as, the radius value you have to calculate. Means previous question alli en madidvi, a formula radius is equal to, you can take. First copy down the values. Electron energy is 1800 electron volt. Magnetic field is 0.4. Charge is 1.6 into 10 raised to minus 19. Mass of the electron is 9.1 into 10 raised to minus 31. So here you can see the radius is equal to, so previous question we have seen the radius is equal to mv upon bq anta ide. So therefore mv upon bq, q means here electron anta helidare. Therefore we can write it as radius is equal to, it is m into v upon b into e. So this is equal to m into b into e. Here velocity can be written as 2e upon mass. How we are getting this? From the kinetic energy expression. So kinetic energy is equal to half mv square. So now what we can do, this equation, we can write it for velocity is equal to. Okay, so velocity is equal to idenagatte 2e upon m. So it is v square, therefore you make it as under root of 2e upon m. So why we are taking this here, students? Because in the question, they have not given you the velocity value. You can see, ನೀವು ಈಗಷ್ಟೇ copy down ಮಾಡಿದ್ದೀರಾ values ಅನ್ನ, you can see velocity ಕೊಟ್ಟಿಲ್ಲ ಅಲ್ಲಿ. So when velocity is not given, what is the alternative method? You can go for the energy and velocity relation. How you can get it? From the kinetic energy expression. So from kinetic energy, half mv square, here you will get velocity in terms of energy. Because in the question, energy is equal to, it is specified it as something 1800 electron volt. Understood? So why we are doing this one? Therefore, now the solution is in front of you. So energy is equal to half mv square. Idralli velocity is equal to 2e upon m, that is under root because v square is there. This is velocity. The next step, the radius is equal to, we know that mass into velocity upon be from the previous expression. Now m upon be, v value is 2e upon m. So now you have all the values. You can just substitute and you can try to simplify that. And one more thing, here energy, they have given it as 1800 electron volt. So 1800 electron volt anta andre 1800 into electron volt ಇದ್ದದನ್ನ ನಾವಿಲ್ಲಿ ಬರೀ ವೋಲ್ಟ್ ಆಗಿ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಅಂದ್ರೆ ಜೂಲ್ಸ್ ಅಲ್ಲಿ ಮಾಡ್ಕೋಬೇಕು. ಸಾರಿ, ಜೂಲ್ಸ್ ಅಲ್ಲಿ ಮಾಡ್ಬೇಕಂದ್ರೆ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ 1.6 into 10 raised to minus 19. 1.6 into 10 raised to minus 19. Okay, so therefore ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ನೋಡಿ, under root of 2 into 1800 into 1.6 into 10 raised to minus 19 into mass of the electron. That is 9.1 into 10 raised to minus 31. ಅಪಾನ್ ಬಿಇ ಇದೆ. ಬಿ ಅಂತ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ 0.4 ಅಂತ ಇದೆ. ಇ ಅಂದ್ರೆ ಚಾರ್ಜ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್, ದಟ್ ಇಸ್ 1.6 into 10 raised to minus 19. ಓಕೆ, ಸೊ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 3.58 into 10 raised to minus 4 ಅಂತ ಬರುತ್ತೆ. ಸೊ ಥಿಯರಿ ಇಫ್ ಯು ನೋ ಪ್ರಾಪರ್ಲಿ ಈಸಿ ಅನ್ಸುತ್ತೆ, ಅದರ್ವೈಸ್ ನಿಮ್ಗೆ ಟಫ್ ಅನ್ಸುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಕಂಪ್ಲೀಟ್ ದ ಥಿಯರಿ. ರೀಡಿಂಗ್ ಥಿಯರಿ ನೀವು ಸರಿಯಾಗಿ ಮಾಡಿದ್ರೆ ಸಿಇಟಿ ಆಕ್ಚುಲಿ ಅಷ್ಟು ಟಫ್ ಆಗಲ್ಲ ಕಂಪೇರ್ಡ್ ಟು ಆಲ್ ದೀಸ್ ಇಯರ್ಸ್. ಸೊ ಜೆ ನೀಟ್ ಲಿಟಲ್ ಬಿಟ್ ಕ್ವಶನ್ಸ್ ವಿಲ್ ಬಿ ಟಫ್, ಬಟ್ ಸಿಇಟಿ ಮಾಡ್ಬೋದು ಈಸಿಯಾಗಿ, ಬೋಲ್ಡ್ ಸಿಲೆಬಸ್ ಸರಿಯಾಗಿ ರಿವೈಸ್ ಮಾಡಿದ್ರೆ. ಓಕೆ, ಸೊ ಇದೆಲ್ಲ ನಿಮ್ಗೆ ಟಫ್ ಅನ್ಸ್ಬೋದು, ಬಟ್ ನಿಮ್ಗೆ ಒಂದ್ಸಲಿ ನೀವು ಏನ್ ಫೈನಲ್ ಎಕ್ಸಾಮಿಗೆ ಪ್ರಿಪೇರ್ ಆಗ್ತೀರಾ, ದಟ್ ಟೈಮ್ ಯು ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಫೀಲಿಂಗ್ ದೀಸ್ ಕ್ವಶನ್ಸ್ ಆರ್ ಈಸಿ. ಓಕೆ, so now you may feel little difficulty in understanding these numericals. So next question, then after that we will go for, that is magnetism and matter. See, when a positively charged particle enters a uniform magnetic field with uniform velocity, its trajectory can be a straight line, a circle or a helix. So ಯಾವ್ದಿರತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. The question meaning is what? See here, when a positively charged, you have ನಿಮ್ಮ ಹತ್ರ positively charged particle ಇದೆ, ಇದು ಎಲ್ಲಿ ಎಂಟರ್ ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಎಂಟರ್ ಆಗ್ತಾ ಇದೆ. ಇಮ್ಯಾಜಿನ್ ದಿಸ್ ಇಸ್ ಎ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಯುವರ್ ಚಾರ್ಜ್ ಈಸ್ ಎಂಟ್ರಿಂಗ್ ದಿಸ್ ಒನ್. ಓಕೆ, ಸೊ ಇಟ್ ಇಸ್ ಎಂಟ್ರಿಂಗ್, ಇಟ್ಸ್ ಟ್ರಾಜೆಕ್ಟರಿ ಕ್ಯಾನ್ ಬಿ, ಟ್ರಾಜೆಕ್ಟರಿ ಅಂತ ಅಂದ್ರೆ ಈ ತರ ಏನು ಪಾರ್ಟಿಕಲ್ ಮೋಷನ್ ಇರುತ್ತೆ ಇದಕ್ಕೆ ಟ್ರಾಜೆಕ್ಟರಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ಇನ್ ದ ಫಸ್ಟ್ ಇಯರ್ ಅಗೇನ್ ನೀವು ಟ್ರಾಜೆಕ್ಟರಿ ಮೋಷನ್ ಅಂತ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ. ದ ಬಾಡೀಸ್ ವಿಚ್ ಆರ್ ಇನ್ ದ ಫ್ಲೈಟ್ ಮೋಡ್ ಮೀನ್ಸ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದ್ ಬಾಲ್ ಅನ್ನ ಇಲ್ಲಿಂದ ಈ ಕಡೆ ಒಗದ್ರೆ ಇದೇನಿಲ್ ಪಾತ್ ಫಾಲೋ ಮಾಡತ್ತಲ್ಲ, ಇದಕ್ಕೆ ಟ್ರಾಜೆಕ್ಟರಿ ಪಾತ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ಟ್ರಾಜೆಕ್ಟರಿ ಮೋಷನ್ ಅಂತ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ. ಸೊ ಅವ್ರ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಯಾವ ರೀತಿಯಾದಂತ ಪಾತ್ ಅನ್ನ ಫಾಲೋ ಮಾಡತ್ತೆ, ಸ್ಟ್ರೇಟ್ ಲೈನ್, ಸರ್ಕಲ್ ಆರ್ ಎ ಹೆಲಿಕ್ಸ್. ಸೊ ಓನ್ಲಿ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಇರತ್ತಾ, ಅಥವಾ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಮತ್ತೆ ಸರ್ಕಲ್ ಇರತ್ತಾ, ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಮತ್ತೆ ಹೆಲಿಕ್ಸ್ ಇರತ್ತಾ, ಆರ್ ಎನಿ ಒನ್ ಆಫ್ 1, 2 and 3? It is option D. It may be any one of 1, 2 and 3. Why? Because it depends on other factors also. Okay, so here it depends on other factors, therefore we cannot predict which andre ade baratte anta in conclusion illa. So it may be a straight line, it may be a circle, or it may be a helix also. Okay, so I'll share next part, magnetism and matter. Just a minute, I'll share the magnetism and matter questions. Yes, you are able to see no PPT? So why I am taking this lesson also, because purely theory questions baratte from magnetism and matter. So from CET point of view, magnetism and matter hardly one question will come. So adke idravatte cover ಮಾಡ್ತಾ ಇದೀವಿ. Maximum theory questions are there from this chapter. Which one of the following is correct about the magnetic monopole? So first I'll tell you the options, then I'll tell you what is monopole. Magnetic monopole exists. Magnetic monopole does not exist. Magnetic monopole have constant value of the monopole moment. The monopole moment increases due to increase at its distance from the field. Monopole andre gottidya? Yes, monopole, you know what do you mean by the monopole? See, monopoles ಅಂತ ಅಂದ್ರೆ ನೀವು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು ಮ್ಯಾಗ್ನೆಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, as you know that magnets are having two poles, south and the north pole. Okay, suppose if I cut this magnet into two parts, ಇದನ್ನ ಎರಡು ಪಾರ್ಟ್ ಕಟ್ ಮಾಡಿದ್ರೆ here what happens, again it will have north and south pole. ಕಟ್ ಮಾಡಿದ್ರು ಕೂಡ ನಿಮ್ಗೆ ನಾರ್ತ್ ಮತ್ತೆ ಸೌತ್ ಪೋಲ್ ಬರುತ್ತೆ. Again if you cut it, again you will have south and north pole. Okay, again if you cut it, ಮತ್ತೆ ಎಷ್ಟು ಚಿಕ್ಕದ್ ಮಾಡ್ತೀರಾ ಅಷ್ಟು ಚಿಕ್ಕದ್ರಲ್ಲೂ you will have north and the south pole. If you make small part also, both that a part is also having north and south pole. ಎಷ್ಟೇ small piece ಮಾಡಿದ್ರು both poles will be there. Okay, so monopoles anta andre only one pole. Monopole means single pole. Single pole means either it is a south pole or it is a north pole. So ಯಾವ್ದಾದ್ರು ಒಂದೇ pole ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So which one of the following is correct about the monopole ಅಂದ್ರೆ monopole does not exist only. Okay, so monopoles ಅಂದ್ರೆ single pole. ಅಂದ್ರೆ ನೀವು ಕಟ್ ಮಾಡಿದ ಕೂಡಲೇ ಬರೀ ಇಲ್ಲಿ ನಾರ್ತ್ ಅಷ್ಟೇ ಉಳಿಯುತ್ತೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ನೋ, ಸೊ ದಿಸ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ನೀವು ಎಷ್ಟೇ ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ ಮಾಡಿದ್ರು ಮ್ಯಾಗ್ನೆಟ್ ಇಟ್ ವಿಲ್ ಹ್ಯಾವ್ ಬೋತ್ ದ ಪೋಲ್ಸ್, ದಟ್ ಇಸ್ ಸೌತ್ ಅಂಡ್ ದ ನಾರ್ತ್ ಪೋಲ್. ಸೊ monopoles does not exist. Okay, next question students. Yes, which one of the statement is true? A freely suspended magnet comes to rest in south north direction. Opposite poles of the magnet attract each other. Earth behaves as a gained magnet. All of this, which is true. All of this. Yes, all these are true statement. Opposite poles attract. Earth behaves as a gained magnet andre dod magnet tara behave ಮಾಡುತ್ತೆ. A freely suspended magnet comes to rest in the north south direction. Next, magnetic moment for a solenoid and corresponding bar magnet is, magnetic moment of a solenoid and corresponding bar magnet is equal for both, more for solenoid, more for bar magnet, none of this. So solenoid, I don't know ನಿಮ್ಗೆ ಗೊತ್ತಿದೆಯಾ ಇಲ್ಲ ಅಂತ. So solenoid means here, for example, if I take one iron rod. Okay, so ಇದೊಂದು iron rod ಇದೆ. For this iron rod, ಒಂದ್ ವೈರ್ ಅನ್ನ ಈ ತರ ಉಂಡ್ ಮಾಡ್ತೀವಿ, ಅಂದ್ರೆ ಇದನ್ನ ಸುತ್ತೀವಿ. ಫಾರ್ ದ ಐರನ್ ರಾಡ್ ವಾಟ್ ವಿ ವಿಲ್ ಡೂ, ನಾವಿಲ್ಲೊಂದು ವೈರ್ ನಾವಿಲ್ಲಿ ಇದಕ್ಕೆ ರೋಲ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಓಕೆ, ಸೊ ವೆನ್ ಯು ಪಾಸ್ ದ ಇಲೆಕ್ಟ್ರಿಸಿಟಿ ಟು ದಿಸ್, ನೀವು ಯಾವಾಗ ಇಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್ ಮಾಡ್ತೀರಾ that time this behaves as what, ಇದು ಸೊಲನಾಯ್ಡ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ. ದಿಸ್ ಆಕ್ಟ್ಸ್ ಲೈಕ್ ಎ ಸೊಲನಾಯ್ಡ್. ಓಕೆ, ನೀವು ಕರೆಂಟ್ ತೆಗೆದ್ರೆ ಅದು ಸೊಲನಾಯ್ಡ್ ಇರಲ್ಲ, ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿದ್ರೆ ಇದೇನಿಲ್ಲ ಆಗ್ತಾ ಇದೆ, ದಿಸ್ ಬಿಹೇವ್ಸ್ ಆಸ್ ಎ ಸೊಲನಾಯ್ಡ್. ಓಕೆ, ದಿಸ್ ಇದೇನ್ ಸಿಸ್ಟಮ್ ಇದೆ, ಈ ಸಿಸ್ಟಮಿಗೆ ಸೊಲನಾಯ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಮತ್ತೆ ಈ ಫಿನಾಮಿನಾಗೆ ಇಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂವ್ಮೆಂಟ್ ಸೊಲನಾಯ್ಡ್ ಮತ್ತೆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟಿಗೆ ಸೇಮ್ ಇರತ್ತಾ, ಜಾಸ್ತಿ ಇರತ್ತಾ, ಅಥವಾ ಯಾವ್ದು ಟ್ರೂ ಇಲ್ಲ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಹಿಯರ್ ಆಪ್ಷನ್ ಎ, it is equal for both. Since a bar magnet and the corresponding solenoid produce similar magnetic field, ಎರಡು similar magnetic field produce ಮಾಡೋದ್ರಿಂದ the magnetic movement will be same. Okay, this is little blur, leave it. Next question. A short bar magnet has a magnetic moment of 0.48 joules per Tesla. The magnitude and direction of the magnetic field produced by the magnet at a distance of 10 centimeter from the center of the magnet on its axis is. So you need to calculate the value of the magnetic field. Copy down the value. Simple agide. Magnetic moment value is 0.48 joules per Tesla. Then distance is 10 centimeter. Copy down the value. Only 3 values are there. See. So we have only one formula in this chapter. That is one more time period. Erade formula ide. So that is magnetic field is equal to, it is mu naught upon 4 pi 2 into m upon r cube or d cube. R or d andre distance agate, m andre magnetic moment agate. Mu naught upon 4 pi value students constant ide 10 to the power of minus 7 anta. So magnetic field is equal to 10 to the power minus 7 into 2 into magnetic moment ಎಷ್ಟು ಅಂತ ಹೇಳಿದರೆ 0.48, ಡಿಸ್ಟೆನ್ಸ್ 10 ಸೆಂಟಿಮೀಟರ್ ಅಂತ ಇದೆ, ಮೀಟರ್ ಅಲ್ಲಿ 10 into 10 raised to minus 2. ಸೊ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 2 1s ಆಗತ್ತೆ, 2 5s ಆಗತ್ತೆ. So this is 10 raised to minus 2 ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ plus 2. So 10 raised to minus 5 into 0.48 upon 5. So simplify ಮಾಡಿದ್ರೆ it will be 0.96 into 10 raised to minus 4 along north-south direction. You can copy down the solution. Okay, the next question, another some 2-3 questions we will see. So this is similar one. You can see each chapter ಅಲ್ಲಿ almost ಒಂದೇ pattern ಅಲ್ಲಿ question ಬರುತ್ತೆ. That is a short bar magnet, that is magnetic field, distance. You can see same solution. Everything is same. Okay, so same question ಇದೆ. We will leave that. Here also this is based on the same pattern, but ಇಲ್ಲಿ see the magnetic induction at a point 1 angstrom away from a proton measured along its axis of spin is moment, magnetic moment is given as 1.4 into 10 raised to minus 26 ampere meter square. You can copy down this. ನೀವು ಆಮೇಲೆ ಬೇಕಾದ್ರೆ try ಮಾಡಿ. So same formula, we will have different questions. Copy down the question, later you can try this. Okay. So one thing you remember, that is the distance is given as 1 angstrom. So 1 angstrom means 10 raised to minus 10 meter. Okay, that much you remember. So remaining all solution will be same pattern. So this is also on the same formula. You can copy down this. The magnitude of the equatorial magnetic field due to a bar magnet of length 2 centimeter at a distance of 1 meter from its midpoint is. Here magnetic field you need to calculate. Magnetic moment is given. Length is given. So you can see mu naught upon 4 pi. It is m by r cube. Why? Because it is, see what they have specified. See, the magnitude of the equatorial bar magnetic field due to a bar magnet of length 2 centimeter at a distance of 1 meter from its mid-air. Okay, so from the midpoint they are considering. From the midpoint they are considering. Therefore, here the formula becomes mu naught upon 4 pi capital M by R cube. So 2m ತಗೊಳ್ಳಲ್ಲ, m by R cube ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. That is 10 raised to minus 7 into 0.60 upon the distance is 1 meter, not 2 meters. Okay. Why? From the midpoint they are asking you to calculate. ಸೊ ಟೋಟಲ್ ಕೇಳ್ತಾ ಇಲ್ಲ. ಟೋಟಲ್ ಅಂತ ಅಂದಿದ್ರೆ 2m ಬರ್ತಿತ್ತು ಅಂಡ್ ದ ಟೋಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಬರಬೇಕಿತ್ತು. ಬಟ್ ಹಿಯರ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಯು ಫ್ರಮ್ ದ ಮಿಡ್ ಪಾಯಿಂಟ್. ಸೊ ಇಟ್ ಇಸ್ 6 into 10 raised to minus 8 Tesla. You can see here, students. So same pattern questions are there. Only they have just modified that one. Howda. So what I'll do, this whatever the PPT is there, I'll forward you this PPT. Okay, so what you can do, you can just try these questions because only 2 formulas are there. So lesson al bari 2 formula matra baratte. Ader melene repeated bere bere pattern questions ide. So you can try it by yourself. You can try one this question. So this is little bit based on the torque part. You can see a bar magnet has a magnetic moment of 200 ampere meter square. Okay, magnetic moment is 200 ampere meter square. And it is suspended in a magnetic field of 0.3 Newton per ampere per meter. The torque required to rotate the magnet from its equilibrium position through an angle of 30 degree will be. Copied on the question, I'll tell you the solution. See, the torque experienced by the magnet is given by tau is equal to mv sine theta. So this is given by tau is equal to mv sine theta. The magnetic moment is, it is 200 ampere meter square. The magnetic field is 0.30. Theta value is 30 degrees. So sine 30 is 1 by 2. We know that already. So if you simplify, the torque value will be 30 Newton meter. So torque, time period, and the magnetic field. Only 3 formula questions will come. So this also not from this chapter actually. The formula now previous chapters alle kalitivi. Yes, completed? Okay. So here in the previous one question, you asked about if it is parallel, what will be the formula. So here actually, after that one question we discussed, that is when the charge is moving in a circular path. Here what happens, this is due to the magnetic field. The expression, the force expression is given by qvb sine theta because it is a charge. Okay, next here one more force which is acting, that is the magnetic force. So sorry, the centripetal force, it is mv square by r. So the magnetic force will be, it is qvb sine theta. Theta value ಅವ್ರು ನಿಮ್ಗೆ ಏನ್ ಹೇಳ್ತಾರೆ, whether they are specifying it as 30 degree, 45 degree, 0 degree, or it is 90 degree, perpendicular, parallel, anti-parallel. Anti-parallel ಅಂದ್ರೆ 180 degree ಬರುತ್ತೆ. So based on that force you can calculate. First thing. Second thing, force ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಕೇಳಿದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ, you have to equate qvb is equal to mv square by r. So theta ಬೇಕಿದ್ರೆ ತಗೊಳ್ಳಿ. If the angle is not given, don't take sine theta. Okay, so theta 30 degree ಗಿಂತ ಕಡಿಮೆ ಇದ್ರೆ they will not give in the question. So if it is given, take sine theta. If it is not given sine theta value, leave it. So just equate these two equations. qvb is equal to mv square by r. For this formula, what you need to do, whether they are asking you for the radius ಗೆ ಫಾರ್ಮುಲಾನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಳಿ. Whether they are asking you for the velocity, ಫಾರ್ಮುಲಾನ ವೆಲಾಸಿಟಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಮಾಸ್ ಕೇಳಿದ್ರೆ ಮಾಸಿಗೆ ಆ ರೀತಿಯಾಗಿ ನೀವು ಮಾಡಿಫೈ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಓಕೆ, so you just need to equate these two equations and modify what is asked in the question. Is it clear?
Yes, ma'am.
Okay, so this PPT I'll forward you. You can take it from the sir. Then later you can try after your exams, whenever you will get time. Okay, So you can just practice because repeated same formula ಮೇಲೆ questions ಇದೆ. Okay. So we will meet in the next class, students. So from part 1, all the lessons we have completed. So in the next class, part 2, ray optics in the start ಮಾಡೋಣ ಅಥವಾ semiconductors in the start ಮಾಡೋಣ. Okay.
Yes, ma'am.
Bye, students. Take care.
Thank you, ma'am.